All right, for number 2, I have no factoring to do because this is already factored for me. So I'm just going to go straight into finding my important info. So the first thing I'm going to look for is if anything cancels. Nothing's going to cancel on the top and the bottom, so there's going to be no holes. Then I'm going to look for vertical asymptotes. Everything that makes the denominator equal to 0 in the simplified version of the fraction is going to be a vertical asymptote. I know that this is my simplified version of my fraction since nothing canceled. So I have x equals 3, x equals 2, x equals -4, and x equals 0 are my vertical asymptotes. For the domain, I'm going to draw a little number line here. And everything is allowed for me to plug in for x for this graph, or everything's going to be shaded except for these x values here. And then if I had any holes, those x values would also not be included in the domain. So I'm just going to make a number line from least to greatest. I have -4, then 0, then 2, then 3. These are not included, so I'm going to put open circles on them. And then I'll have 1, 2, 3, 4, 5 intervals that are going to describe this domain. So the first interval is -∞ to -4, then -4 to 0, then 0 to 2, then 2 to 3, and then 3 to infinity. I'm going to circle one horizontal asymptote or oblique asymptote. I have to find what the highest power term is in the top and the bottom. So I'm going to multiply the highest power term in each factor together, and I'll get x cubed is my highest power in the numerator. And then I'll do the same in the denominator, and I'll have x times x times x times x, which is x to the 4th power in the denominator. So I know that n is less than d, which means this is a proper fraction, which means it's the proper situation that my horizontal asymptote is y equals 0. So I have a horizontal asymptote, and the end behavior is 0. So the limit as x goes to positive or negative infinity of f of x is equal to 0. For the y-intercept, I plug in x is 0, and if I do that in this equation that I have, I'm going to end up with an undefined answer, which means I actually do not have a y-intercept. Then for zeros, I'm looking for everything that would make the numerator equal to 0. So that's -5, 6, and -1. And then I'm going to plot all this important info. So I have -1, 6, and -5. -1, 1, 2, 3, 4, 5, 6, and -5. 1, 2, 3, 4, 5 right here. And then I have a horizontal asymptote at 0. I'll put that in last. 3, 2, -4, and 0. 3, 2, -4, 1, 2, 3, 4, and 0. Okay, and then I have just the horizontal asymptote, which I'm only going to include on the sides, and then I'm going to try to draw my smooth curves. I don't have enough information, unfortunately, with the important points and the important lines that I drew to draw anything else. I'm going to have to plug in a point. So I already have this x-intercept for this piece here that's going to go between those two vertical asymptotes. So I'm going to pick f is -2 and see what happens. So I'm going to do, not f is -2, f of -2, or where x is equal to -2, and see what I get for this. So I'll end up with -2 plus 5, which will give me 3. -2 minus 6, which will give me -8. -2 plus 1, which will give me -1. And then divided by -2 minus 3, which is -5. -2 minus 2, which is -4. -2 plus 4, which is 2. And just -2. And then I'll end up with, in the numerator, 24, positive 24, and 20, 40, -80 in the denominator. So this is going to be a negative number. I have -2 and like -1/3-ish. So I know as I go to the left, I'm going to be going down to reach that vertical asymptote. And as I go to the right, then I must be going up, because this is not a special x-intercept. So it's not a bounce, and I shouldn't have any other x-intercepts in between here and here. I found all my x-intercepts. That means that between these two vertical asymptotes, I need to be approaching this vertical asymptote on the left downwards, because it's not special. And then I can't be going through the x-axis at all, so I need to turn around at some point and go back down, which means the piece here will be an upwards parabola. You're just sketching it. It doesn't have to be perfect, as long as you're not going through the x-axis, because there's no x-intercepts there. And then because of that, I'll be approaching this vertical asymptote from the right downwards. And then as I go to the right, I'm going to be turning around at some point to get closer and closer to 0. My left piece, I'll be going upwards to get to that vertical asymptote, then through that point and around, going closer and closer to y = 0. And that's what my graph should look like.